With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given with that we need to determine the length of iron rod and copper ruler at 0 degrees Celsius if the difference in their length at 50 degrees C and 40 degrees C is same and is equals to 2 centimeter, and the coefficient of linear expansion for iron is given as to be 12 into 10 raised to the power minus 6 per Kelvin, and that of copper is 17 into 10 raised to the power minus 7 per Kelvin. So let's say we don't know whether this iron rod is bigger or this copper rod is bigger, so we just assume that let's say this is our iron rod and this is, let's say, our this copper. This is our iron rod, this is our copper ruler. So we will be denoting iron, so this would be our Fe and this would be our Cu. We will be denoting this by 1 and this by 2. Let's say initial length at x equals to 0, here is x, here it is y. We know that length at any this temperature is given as to be with respect to our 0 degree C. It would be equals to length at any temperature would be equals to length at 0 degree, then 1 plus alpha, which is the coefficient of linear expansion of any material, whether it is for iron or for copper, and then the temperature, okay, to which we have raised from the 0 degree Celsius. Okay, now in the first case at, we say that when temperature, so this is our temperature, we are denoting as small t. So at temperature, when the temperature is our 50, we call this temperature as to be our T1, which is equals to 50 degrees C. So in the exact equation, it is delta T, that means the change in temperature. But since initial temperature is 0, so here we can just directly write the temperature to which we have heated. So we need to find what we have been given. We have been given that difference in length is same. Okay, so we can say that our delta L in the first case, okay, in the initial, this would be equals to let's say this is basically the length is more, so we say that length of 1 minus length of 2. So basically this final length would be dependent upon two factors. It is dependent upon the initial length and also upon the value of alpha, okay, because the temperature is same for both, so it will also be dependent upon the value of alpha also. Okay, so clearly we can see that for copper it is greater, so we just first of all we just write this. So for our iron, L naught would be equals to x initial length. This is situation is at T equals to 0. So this would be our L naught for iron, this would be L naught for copper. So we can just write, plug in the values. Next, 1 plus alpha 1 T1 minus y 1 plus alpha 2 T1. So this temperature is T1 and the temperature value is same for both. Alpha is different for both, so we have used the subscript 1 and 2. Now in the second case, when our temperature at, so let's call this as to be equation 1. Now when temperature is T2 and this is equals to 450 degrees C. Now in this situation, what is our delta L? Again it would be this minus this. So we don't know whether the copper length of copper would be greater or length of this iron would be greater, because we have seen that it is dependent upon two factors, this and this. Okay, so here we will be taking a positive negative sign, okay, because this could be L1 minus L2 or it could be L2 minus L1. So it is better to take delta L to be positive and negative. Now if we take again if we do, so it would be x 1 plus alpha 1, then temperature is T2 minus y 1 plus alpha 2 into T2. Let's say this is our equation 2. Now it is given that this L1, let's call this as to be our L1, delta L1, this to be our delta L2. It is given that L1 and L2 is basically same. So taking positive sign, taking positive sign, so magnitude wise it is equal. So delta L1, this would be equals to our delta L2. We can write it like this. So from 1 and 2 we can equate. So if we put the values, so delta L1 we put the value, so it would be equals to x 1 plus alpha 1 T1 minus y 1 plus alpha 2 T1. This value would be equals to this value, x 1 plus alpha 1 T2 minus y 1 plus alpha 2 T2. So we have just equated 1 and 2 with taking as the sign to be positive sign. So if we expand this, clearly we can see that this x and this x would be gone, this y and this y would be gone. So it would be ultimately it would be x alpha 1 T1 minus y alpha 2 T1. This value would be equals to x alpha 1 T2 minus y alpha 2 T2. Okay, now what we can do, we can take the x to be the one side and y to be the other side. So if we take do like this, so it would be x alpha 1 t1 minus x alpha 1 t2. This would be equals to, if we take to the other side, this to the other side, y alpha 2 t1 minus y alpha 2 t2. Okay, clearly we can see that we can take x1 alpha 1 to be common, then here it would be t1 minus t2. Similarly, we can see that y alpha 2 to be common, so it would be t1 minus t2, and that would be cancelled. So on simplifying, we get the result as x times alpha 1. This would be equals to y times of alpha 2. Okay, now we can say that our x would be equals to alpha 2 divided by alpha 1 into y. Now this is, let's say this, call this as to be our equation 3. Now what we have given, we have been given that initial the difference in length is 2 centimeter. Now if you put the value of let's say x into equation 1, or we can put the value of x into equation 2, we can get the value of the y. So if we do this, if we substituting x from 3 to 1 or 2, any of the equation, okay, we can get the value, because for both delta L would be same. Then our y would turn out to be, if we put the values, so it would be equals to alpha 1 divided by alpha 2 minus of alpha 1 and then delta L. So if you put the values, so alpha 1 value is given as to be alpha 1 is 12 for the iron, 10 raised to the power minus 6. So here it would be alpha 2 is for the copper, so 17, because 10 to the power minus 6 power is same, so we can just take the power to be common, multiplied by the length. So it is given as to be 2 centimeter. If we solve this, this would turn out to be 4.8 centimeter. Now we can put the value of y into this equation to get the value of x. So x value would be equals to alpha 2 divided by alpha 1, that means 17 into 10 raised to the power minus 6 divided by alpha 1, 12 into 10 raised to the power minus 6 multiplied by y, which is 4.8. So if we solve this, this would turn out to be 6.8 centimeter. So one is the case when x could be equals to 6.8, y could be equals to 4.8. That means one length. But here we see that no option is matching this. So what we need to do, we need to then take the negative sign. Okay. Similarly, this we have taken when we have taken positive sign. Similarly, if we do taking negative sign in equation 2, and then simultaneously solving 1 and 2. If we do this 1 and 2, so we will be getting the value of y as, so we just need to equate this. Similarly, we have shown one result like this. Similarly, what we can do, we can just substitute these two, but here we are taking the negative sign, delta L1, delta L2, these value would be same. So if we do this like this, then our y would turn out to be 2L plus L times alpha 1 T1 plus T2 divided by T2 minus T1, difference of the temperature, T2 minus T1 multiplied by alpha 2 minus of alpha 1. So if we calculate this, if we put the value, so it would be 2 into 2 plus length is 2, alpha 1 is 12 into 10 raised to the power minus 6. T1 is, we have seen that it is equals to, T1 is 50 and T2 is 450 divided by the difference of the temperature. So if we take the difference 450 minus 50, it would be equals to 400. Then alpha 2 minus alpha 1, we can say that 17 minus 12, and the power 10 raised to the power minus 6 is the common one. So from here we can see that our y value, if we solve this, so our y would turn out to be 2006 centimeter, or we can say that it would be 20.06 meters. Now similarly, the value of x would be equals to x. Similarly, the value of x, if you put this, substitute the result, so x value would turn out to be 2L plus L alpha 2 T1 plus T2 divided by T2 minus T1 multiplied by alpha 2 minus alpha 1. Or what we can do, we can just put the value of y in any of the equation to get the value of our x. So our x would turn out to be 2, L value is 2 plus L value is 2 into alpha 2, which is 17 into 10 raised to the power minus 6. Then it would be T1 plus T2, 450 plus 50, it would be 500. Then it would be divided by T2 minus T1, that means 400. And then alpha 2 minus alpha 1, we can see there 17 minus 12, it would be 5 multiplied by 10 raised to the power minus 6. Now if we solve this, then our x value would turn out to be in centimeter, it would be 2008 centimeter, or we can say that it would be 20.08 meters. So one length would be 20.08 and another length would be 20.06. If we check the option, one length is 20.06, another length is 20.08. That means A is the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.